Here's a little Desmos uh, uh, page that I'm going to share with you guys. You can see here that I'm looking at this arbitrary thing that I'll call a linear fractional because it's two linear equations in a fraction. And then we have our, the parameters A, B, C, and D sitting right there. Okay. And you can see here that there's a graph of a line here, and that's the graph of this one. And you can see in this case, it is a constant, and the constant value is -2. Okay. You can look and see this ourselves, right? So this is 2x, 2x minus 2 over minus x plus 1. And you can factor out the 2 on the top and factor out a -1 on the bottom, and you're going to get -2, right? And then you'll have x minus 1 over x minus 1, and those will just cancel, right? So you end up with 2 there as a, if you were to simplify this, right? Now with this thing, you can kind of play with this, and you can change the values of a, b, and these things, and you can see what happens, right? As we sort of move this around, right? This, various kinds of things can happen here. The sort of typical shape of this is a hyperbola, right? That isn't constant, right? And so the goal of part two of your question is to come up with what conditions on these A, B, C, and D actually make this thing constant, right? So let's see if we can get one sort of constant. Well, actually, first of all, let's look at a couple let me make this a little bit simpler. Let's make this, let's say a 2, and we'll have -2, and let's make this -2 and say -3, right? So something like that. If you actually look at this equation here, you have 2x minus 2 over -2x minus 3. As x gets really, really big, going out this direction or going out this direction, right, then this -2 and -3, are kind of small compared to 2x and -2x. So this fraction right here becomes really close to just 2x over -2x, which is the same as -1, right? So as x sort of goes out toward infinity here, and towards minus infinity over here, this green line, which is the graph, is going to approach -1, which is this dotted line right there, right? And this dotted line right here is where, the bottom is 0. This is where you're dividing by 0, right? So these things are never defined at the point minus, it'll be what? It'll be minus -3 over -2. So it'll be 3 over -2, which is -3 over 2. So that's this point right there, right? So you can see what those two blue lines are doing. And then this is always a point that's not in the domain of this function. And the point here is to see, what happens, what are the conditions on these so that, in fact, this green line just goes and lies on this constant line right there, right? So here, these aren't canceling out in the right way, but if I take this -3 and start sliding it over, let's see, well, I said I need to slide it way over here towards 2 actually. And you can see it's kind of closing in and you can see it kind of just touches and then flips up like that, right? But there, right at that point, right, these things are now canceling out again, right? And so this is just, y is just -1, just the flat function -1, right? Except at the point, right here, which is at what, x equals 1, right? So that point's not in the domain of this, right? But otherwise, it's just a constant function, right? So this is the kind of thing you're looking at, and you're trying to come up with the conditions on A, B, C, and D that guarantee that you don't have this situation right here, where y is just a constant function. That's what you're trying to do in part two of your DQ.